Hi everybody, this is Miss Folly, and welcome to our podcast on the Chatelier's principle. So, in the Chatelier's principle, we're going to talk about what happens when you add or remove a reactant, temperature and delta H, volume and pressure, and a catalyst speeds up both directions. So let's hop to it. For the Chatelier's principle, this is kind of the big ugly part. That in any equilibrium, when a stress is made, the system, when a stress is made, the system there, Chatelier's principle states that in any equilibrium, when a stress is made in the system, there's a shift in the position of the equilibrium so as to relieve that stress. Example, stresses. If you add or remove a substance. So clearly you can add something, but you remove it by a side reaction or precipitation. Other stresses are temperature, so you can add heat or remove heat. Pressure, you can increase or decrease pressure, which squeezes. And volume also squeezes. And as a handy little note, it is the opposite of pressure. So, in other words, if I have a volume and these are kind of spread out, if I make it smaller, those same 1, 2, 3, 4, 5, 6 are more compact and the pressure went up. Okay? So, notice here volume went down, but pressure went up from box 1 to box 2. Volume went down, but pressure went up. Those are pressure. All right. So, N2 plus 3H2 makes 2NH3. Delta H is negative 92 kilojoules per mole. If you remember with this delta H, if it's negative, that means heat is a product. So I'm going to go ahead and just put plus heat as a product over here. So if I increase the pressure, it's going to shift to the right-hand side. The reason is, did I lose a page there? No. Okay. The reason is because if you increase the pressure, you want to have to relieve pressure, and the pressure is basically the particles are too close. You shift toward fewer moles of gas. So if I look right here, N2 is 1 mole of gas, H2 is 3 moles of gas. So for my reactants, I have 4 moles of gas. And my products, I have just 2. So it's going to shift to the right-hand side. Reason to relieve the pressure, you shift towards fewer moles of gas. Okay? If I increase the temperature, notice temperature is heat over here. It'll shift to the left-hand side to, remove the extra heat. Okay, so jumping around. So to remove the extra heat. So notice this side, if I go to the right, I'm producing heat. Well, if I increase the temperature, I don't want to produce heat, I want to reduce heat. So I shift to the left, because if I go this way, I will go to the side with less heat. If I increase the concentration of nitrogen and hydrogen, what that means is that I have 2, so if I increase nitrogen and hydrogen, I would have too much nitrogen and hydrogen. So if I have too much of it, I want to get rid of it. To remove, I shift away from it to remove extra N2 and H2. If I increase the concentration of ammonia, this is ammonia, I have too much ammonia. I shift away from ammonia to remove extra ammonia. Now I don't like to say shift right-hand side or left-hand side. I like to say shift away if I add something from NH3. And if I added something here, I want to shift away from N2 and H2. And then if I add a temperature, I want to shift away from heat. I hope you wrote all that down. If I add a reactant, then you have too much reactant, so it shifts towards the product. to reduce the reactant. So instead of towards product, I'm even going to say, if you add reactant, add away. I don't know how you could remember that. Add away. Add away. If you remove, you want to replace. Okay? You have two little reactants, so shift towards reactant. So let's say your name is, I don't know, Danny. Danny likes his dog. Now, if Danny's dog was killed, Danny will replace his dog with a new dog, a better one, a living one, right? So if you lose something, you move to replace it, okay? If you add something, you have too much of it, you shift away from it. So if I gave you, if I gave everybody 200 test tubes, you have too many test tubes, so you'd be happy to give them away to somebody else, right? I hope. Okay. Pressure only affects gases. Increased pressure can be reduced by shifting towards the side with less gas. Decreased pressure can be increased by shifting towards the side with more gas. The increased volume, decreased pressure. The decreased volume, increased pressure. So we talked about that on our first page to go through it, but it only affects gases. And that's important. Heat is temperature. Treat heat as a reactant or a product. Plendo means if delta H is positive, heat goes on the left. Positive. Oops. Left, and that means it's endothermic. So if I tell you that something is endothermic, the heat term goes on the left. If I tell you delta H is positive, the heat term goes on the left. Okay? If you add heat, it shifts toward the side of less heat, or it shifts away from the heat. If you remove heat, you're cooling it, and it shifts to replace it. All right, so let's see what we can do. Increase pressure, so I know I'm going to go to the side with less gas. I have 4 gases here. I have 5 gases here. I have 9 total. Look at my math skills. Woo! Who's jealous? Who's jealous? 4 here, 6 here. That's 10 gases. Oh, faster than you. Board racing champion of Oxbow Elementary. So, increasing pressure, I'm going to go to the side with less gas. So it's going to shift to the left-hand side. Okay. Increased temperature. Oh, look, I've got a negative. So, plendo means positive, left. So negative means it's going to go on the right. So I'll put plus heat. If I increase the temperature, that means I'm going to shift away from heat. Heat is on the left. I'm going to shift away, left-hand side. Yeah. Increase in the concentration of ammonia and oxygen. This is ammonia. This is oxygen. So I'm going to shift away from those. Right hand side. Increase the concentration of nitrogen monoxide and water. Wahaha. So that means I'm going to shift away from them. That means left hand side. Catalyst speeds up a reaction, remember? I remember. So does it speed up for the forward or reverse reaction or both? So if I'm trucking down this way, I can take this shortcut, and it's faster for me. But, ooh, look at this. Look at me do the. If I'm going the other way, I can take this shortcut too. So it speeds it up for both. So equilibrium is achieved faster. So you still get to equilibrium, you just get there faster. Le Chatelier says, if you stress a system, it will shift or relieve the stress. If you add or remove stuff, the K stuff is only for Accel, I'm sorry. Add or remove stuff, then add, away, remove, replace. Oops. Pressure, K is constant, remember. Increased pressure equals less moles. Right? It's both the directions, so less moles of gas. Volume, if you increase volume, then that is going to give you increased volume. Is going to shift to the side with more. Hey, come back! Increased volume will shift to the side with more mole gas. Heat, away. from heat. Catalyst speeds up both directions and does not change the final ratio of product to reactant, so it doesn't change K. That is it. So I say toodles to you. Toodles.